Hello, welcome to another of the videos in the MachStdMill software series. In this video I want to introduce the concept of master tool mode and the use of the tool change position touch plate to measure tools automatically during the tool change. Now, many people are used to using a process where they take tools and when they mount them, what they do is they touch them off to a surface, generally the top of the part, and they set all of their tool length offsets to be relative to that reference surface. So a typical thing to do would be on a CNC machine where you have repeatable height holders. You would come in and you would touch all of your tools to the top surface here. That would end up setting a tool length offset which is dependent upon the physical length of each tool. And once again I want to note that the tool length offset and the physical length of the tool are not usually the same number. Keep that in mind as you read through the manual. That's a common mistake many people make, thinking that those two terms are interchangeable. And in that situation, everything is relative to this surface. Now, that has a serious disadvantage. Suppose the surface that you've used as your reference surface to set your tool length offsets is machined away during making the part, and you need to set a tool after you've lost the reference surface. What do? Well, it's kind of hard because the surface isn't there. A much easier way to go about doing things here, it takes a little bit more to wrap your brain around it, but it's actually generally easier in terms of operation and much simpler once you've got the concepts, is master tool. Now what we've got here is I'm showing you that I've got a drill chuck mounted in the machine, and I'm going to use the drill chuck for all three of these drills. So we will treat all three of these as if they were in non-repeatable height holders, i.e. the chuck doesn't necessarily, when you put the drill back in, make it the exact same length each time you mount it. I'm going to use as my master tool, arbitrarily I'm going to use the middle length drill. That will give me a tool which is shorter than the master and a tool which is longer than the master as I go through this demonstration. Tool length offsets, in the case of a master tool mode, are offsets relative to the physical length of the master tool. So if this were the master tool, one of these tool length offsets is going to be negative and one of them is going to be positive, and we'll see how that works out as we go through the process. So I have Mach fired up here. The machine is referenced. I have a tool change position touch plate installed, and what I want to do is I want to do a tool change and mount a master tool. So the first thing I'm going to do is I'm going to get these tools out of the way so that they're not sitting around here on the table as I start movement. And I'm going to tell the machine that what I want to do is I want to mount tool 100. Now, over here on the tooling page, you'll notice that I have set the master tool number to be tool number 100. So by mounting that tool, I'm telling the machine I am mounting the master tool. Now, let's also talk about a couple of the options I have set up here for tool changes. I have tool change, auto tool change position on. What this option does says every time you do a tool change, as part of the tool change sequence, the machine is to go to the tool change position as part of the tool change. Simple and straightforward. If you have that option on, you can also enable the option that says tool change auto tool length offset. This says, machine, when you change the tool after the user tells you that the tool is physically mounted, measure the tool using the tool change position touch plate and set the tool length offset into Mach's tool table automatically as a result of that measurement. The next option would be, if I was also using repeatable height holders, I can save a little tool change time by telling it to skip the tools that are in repeatable height holders. I'm not going to use that option in this demo. I want to talk here about the situation where you have only non-repeatable height holders. So since I have only non-repeatable height, there aren't any that I want to be skipping. And I have turned on master tool mode because that's the mode I want to demonstrate in this video. There are some other tool length offset modes which are covered in the manual. They are frankly not as convenient as master tool mode, and I have found that once I introduce people to how master tool mode works, they find that's the easiest way for them to run their jobs, and they all tend to like it. So I want to concentrate on that in this set of videos. So what I want to do is I want to mount tool 100. Now, caution. Do not, I repeat, do not succumb to the temptation to go up to the Mach Active Tool DRO and just change the number. That's hidden under my video window here, but you'll notice I currently have tool 0 mounted, i.e. I have no tool physically in the spindle. Do not click this and change the number. Mach will allow you to do that, and Mach will mess up internally in the 3.43 series and even earlier ones. The problem is that there are numerous bugs inside in the way this is handled in Mach, And if you do it through a tool change sequence, Mach gets it right. If you change it here at the DRO, Mach will not always get it right, and this will come back and bite you sooner or later. So to avoid the bugs that are inherent there, and to get in the good habit, always use the MDI line to do your tool changes. This will not only get the DRO set correctly in Mach, but it will force Mach to go through the tool change sequence, which will actually cause us to do the tool length measurement. If you just change the current tool DRO, what you're doing is you're overriding Mach and saying, by God, the tool number that's mounted is now this, but it doesn't actually perform the tool change sequence, and therefore you don't get the tool measured. Not a good idea. So I'm going to mount T100. T100, M6, and hit the enter. The system moves over to the tool change position and says, hey, I need you to put the tool in. So in this case, I'm going to pick the middle length drill that I had showed you earlier. I'm going to put the bit in the chuck. Now that the bit is mounted, I have physically mounted the tool. You can't see the message up here. Mach is telling you press cycle start after tool change, but you really don't need to see his message window. You can deal with the tool change here and saying mount tool in spindle, which is what MSM is telling you. So I have mounted the tool in spindle. MSM has enabled the dynamic cycle start button, and I am going to tell it to go ahead that I have mounted the tool. It says, all right, since you have mounted the tool and you have the options set, I'm going to go measure the length of this tool. It brings it down to the tool change position touch plate, touches it, and having previously calibrated the touch plate, as shown in another video, we now know the length of this tool. Now, let's find out what it did. I'm going to use the tool browser panel here, and I'm going to come down to tool 100, and you'll notice that what it says is this is the master tool, non-probe. I often run my master tool as my probe tool, and I will cover that combination in a different video. You'll notice that its tool length offset is 0. This may be counterintuitive to some listeners, but this is the correct value for the master tool. Remember, in master tool mode, tool length offsets are always relative to the physical length of the master tool itself. If you take the master tool and you measure its physical length and you subtract from that value the master tool's physical length, well, x minus x is always 0. So the tool length offset for the master tool itself will always be a value equal to 0. As a result of measuring it, this also happens to tell you what the physical tool length is of this setup with that particular drill in the chuck, but it's not really relevant. This is the difference between the physical tool length and the tool length offset. The physical tool length in this case is 6.5670. The tool length offset is 0. And those are the correct numbers here. So I have the master tool mounted. Now, it's interesting that when you're in master tool mode, this is the tool that you must use to do things like set 0 for a surface and set up your part. So what I'm going to do is I'm going to go back to our work coordinate offset page, and I happen to be on the, sorry, I'll scroll down. You can see I'm on the touch off tab here. It's hard to get all of these windows to fit on the screen and still get the video recorder to record everything. So I'm going to jog the machine over to where I'm above this test block that I have in the vise. And we're just going to come over in X until we get somewhere towards the middle of this piece of, it's an aluminum with 2 circles, and I think I was mounting gauges in it at one point, just something that I've used for a bunch of these videos. Bring it over about the middle of the block. And what I'm going to do, because this will show up well in the video, I hope, is I'm going to put my little touch block here, which is battery powered. And what I'm going to do is I'm going to bring the tip of the tool down until I'm almost at the block. I'm going to change to step mode, and I'm going to bring myself back to, oops, went past it, sorry about that, 1,000th step. And what I'm going to do is I'm going to bring us down 1,000th at a time. And when I get down to where I just touched the block, what will happen is we will complete a circuit between the top through the machine to the block, and the block will light up. You can see that the block is now set. I am now touching it. I'm going to back up by 1,000th. I'm no longer touching it. I'm going to change my increment to 10,000ths. I'm going to come down here. I'm just touching the down arrow key until I light up. I'm going to back up one. I'm going to come down. So that's as close as I can.